Hello friends, welcome to our science class. For 10th class student, we are discussing second chapter in science, acid and base. Acid and base, we know already in class 6, 7th, 8th, the acids are sour in taste and base are bitter in taste. But this statement is not sufficient to explain acid and base in 10th class. In 10th class, we read the new definition of acid and base. Acid, the substance that gives H plus ions in aqueous solution, is called acid. Aqueous solution means solution in water. When acid dissolved in water, it gives H plus ion on dissociation. Only those substance that gives H plus ion in aqueous solution is considered acid according to this definition. According to this definition, water is compulsory to identify acid and base because acid gives H plus ion only in aqueous solution according to this definition. So the substance that gives H plus ions in aqueous solution is called acids. Acid turns blue litmus to red. Acid when acid convert or change the color of blue litmus paper to red. Example of some common acids are sulfuric acid, H2SO4, hydrochloric acid, HCl, nitric acid, HNO3. These are also called mineral acids. Here we can see HCl, hydrochloric acid. When it is dissociate in water, it gives H plus ion and chloride ion. Because it gives H plus ion in aqueous solution, therefore it is considered acid. HCl, when dissolved in water, it gives H plus ion. Therefore it is acid. Now you are thinking substance containing hydrogen are acids, but it is not always true. Here we can see glucose containing 12 hydrogen atom, but when glucose dissolve in water, it do not dissociate and do not give H plus ion. Therefore glucose is not considered acid. Alcohol, ethanol, also not acid. It has hydrogen atom, but it is not acid because it do not give H plus ion in aqueous solution. Now you can explain the acid are the substance that gives H plus ion in aqueous solution. Now we explain the base. Base are the substances that give OH negative ions in aqueous solution. Only those substances that dissociates in water to give OH negative ion, hydroxide ion. Base change the color of red litmus paper to blue. The substance which change the color of red litmus paper to blue are considered as base. Example of common bases are sodium hydroxide NaOH, potassium hydroxide KOH. Now we can see here NaOH dissolve in water, it gives Na plus ion and OH negative ion. NaOH gives OH negative ion in water, therefore NaOH is NaOH a base. NaOH means sodium hydroxide is base because it gives hydroxide ion in water. Alkali. Now what is the difference between alkali and base? The bases which are soluble in water is called alkali. जो बेस वाटर सॉल्युबल होंगे उनको हम एल्कली कहते हैं. All bases are not alkali, but all alkalis are considered as base. For example, NaOH dissociate in water gives hydroxide ion. It is also water soluble. Therefore NaOH, sodium hydroxide, is alkali because this base is soluble in water. The base that's soluble in water is called alkali. What is the difference between base and alkali? All base are not soluble in water, but the base which are soluble in water is called alkali. Now this indicator, the meaning of indicator, the substance that indicates. What about it? Indicate about the acid and base. The substance by which we can differentiate between acid and base are called indicator. The common indicator are litmus, phenolphthalein, methyl orange, etc. By the help of indicator, we can distinguish between acid and base. We have two beaker, one contain acid and other contain base. So with the help of indicator, we can easily identify which is acid and which is base. Now, indicators are divided in three categories. First, natural indicator. Natural indicator are the substances which are formed from natural sources. For example, litmus, turmeric, rat cabbage. There is a question in NCERT book related to turmeric. The stain of turmeric becomes reddish brown in soap solution. Why? Turmeric is natural indicator. It has reddish brown color in basic solution. Soap solution is basic. Therefore, when we dip a cloth of turmeric stain, it becomes reddish brown in basic medium. When we wash it, it again becomes yellow. Why the color of turmeric stain on cloth change reddish brown in soap solution? Because turmeric shows reddish brown color in basic medium. These are the natural indicator: litmus, turmeric, rat cabbage. Chemical or synthetic indicator: the substance or the indicator which are synthesized or formed in laboratory is called chemical or synthetic indicator. For example, phenolphthalein and methyl orange. Olfactory indicator. Olfactory indicator means the substance which differentiate in base and acid by the odor or smell. Vanilla has different smell in acidic medium or basic medium. Therefore, it is olfactory indicator. Other example is onion. With the help of onion, we can distinguish between acid and base by the smell of onion. Now the effect of acid on the litmus paper. Acid turns blue litmus to red. This is hydrochloric acid. When we dip a red litmus paper to hydrochloric acid, the color of litmus paper does not change. It remains red. There is no effect of acid on red litmus paper. But when we dip blue litmus to hydrochloric acid, it becomes red. It means acid changes the color of blue litmus to red. Now, effect of litmus on base. Base turns red litmus to blue. When this is sodium hydroxide base. When we dip blue litmus in sodium hydroxide, the color of litmus paper does not change. It means bases have no effect on blue litmus paper. But when we dip red color litmus paper into the basic solution NaOH, it becomes blue. It means base turns color of red litmus paper to blue. By the help of litmus paper, we can easily identify which solution is basic and which is acidic. The substance which turns blue litmus to red is acid, and the substance or solution change red litmus to blue is basic. Now the color of phenolphthalein in acidic and basic medium. Phenolphthalein gives no color in acidic medium. The color of phenolphthalein in acidic medium is colorless, but phenolphthalein gives pink color in basic medium. How we can identify acid or basic solution by the help of phenolphthalein? Phenolphthalein is colorless in acidic medium, but phenolphthalein gives pink color in basic medium. When we add a drop of phenolphthalein in acidic solution, it remains colorless. It means it is acidic. When the solution becomes pink by the adding the drop of phenolphthalein, it is called base. In basic medium, phenolphthalein gives pink color. In acidic medium, phenolphthalein colorless. Now the color of methyl orange in acidic and basic medium. In acidic medium, methyl orange gives red color. In basic medium, methyl orange gives yellow color. In acidic medium, color of methyl orange is red, and basic medium, color of methyl orange yellow. Now we can see here the phenolphthalein. Original color of phenolphthalein is colorless. When it is added to acidic medium, it is colorless. In basic medium, it gives pink color. Methyl orange, original color is red. When it is added to the acidic medium, it is red. But when added to the basic medium, it gives yellow color. Next topic of this chapter will be updated soon on YouTube. Thank you.